I read the question now. Some spring force is brought into the picture. Okay, let me take the diagrams here. There's a string, there's a rod, I'll finish off diagram. Meanwhile, you read the question. Two cases are there. This is what the spring. You try to look at the diagram. So the explanation what he has given. No? So I just put two diagrams here. Stays rod at an angle 15 degrees above the horizontal. This is theta. Then again it's the same theta only. This is the string. Weight of the rod, mg will act. Tension, T1. So try to get into the problem now. Okay, looking at the diagram, I just put this much of information. If in the second case, extension in the spring is eta equal 2 times of that in the first case. There's the first case, there's the second case. If you are able to at least imagine the diagram, I think you can manage here. Let's get into that one. So is telling spring should be elongated or compressed. In the first case, spring should be elongated or compressed. He is not telling. Of course, he said extension, but we must be in a position. Should be elongated only, no? Because we will balance the torque about A. The net torque about A due to weight of the rod mg will be clockwise. Tension will intersect axis of rotation. What is the axis? Axis is passing through point A perpendicular to plane. The axis that one. So torque due to weight will be clockwise. Torque due to tension intersects axis of rotation. So torque due to spring force should be anti-clockwise, no? For it to be anti-clockwise, spring force should act upward. Spring force should act upward means it should be elongated. So I'll show the direction of spring force. So this is the initial thing. Kx1, or if you want to write Kx0. This is the initial elongation. So now the spring force will set up anti-torque which will balance the torque due to weight. So let's directly get into the writing equations now. Torque due to net torque about A should be 0. So for that, this is M1. Weight of the rod, let it be M1, I'll take it. No, M1G L by 2 cos theta. This is clockwise. Then kx naught L cos theta. This should be anti-clockwise. What is this L cos theta? L cos theta is horizontal distance. Look at the triangle. AB equal to L. So perpendicular distance will be L cos theta. So this distance will be L by 2 cos theta. This distance will be L cos theta. So from this, what we get, we'll get initial elongation. So cos theta, L cos will get eliminated. So kx naught is equal to m1g by 2. Call this equation 1. Then along y-axis, tension should balance T1 plus kx naught kx naught equal to how much m1g. So therefore, how much of tension here? Substituting this. So tension in the rod will be m1g by 2. So there's the initial part of the problem. Let's come for the second part of the problem. For vertical equilibrium, it should be elongated. No? So here kx is the spring force. I'll take it. Now what should be kx? Shall I say x should be equal to 2 times x equal to eta x naught. I'll write it. X is equal to eta x naught. That eta is 2 times here. So let's write the equation. So T2 along y-axis, T2 plus kx minus m1g, T2 minus m2g should be equal to 0. This is one equation. Whether it is useful or not, I don't know. Just I'm writing it. Okay, let's go for torque. Torque about which point? I'll go for again about A. Net torque about A will be 0. Wall will set up torque. Torque due to weight. Torque due to spring force also. This will be m1g L cos theta clockwise. T2 is equal to m2. So here T2 into L cos theta clockwise.
Sir,
Due to spring force, kx L cos theta anti-clockwise equal to 0.
sir,
Uh,
sir, how do we know that the tension in both the strings will be T2?
Same or different?
Might be different, no, sir.
You assume different, solve it. If you get T1, T2 equal, okay, fine. But assume better to be different, no?
Yes, sir. So why did we take it to be same, sir?
I took different, no? T1, T2, are you not seeing?
Sir, in case 2, sir. Sir, in case 2, sir. T2 is the same, no, sir. You put T2 the same for
Okay,
both
okay.
the
Oh,
strings.
these two tensions. I'll
Yes,
do one
sir.
thing. I'll do one thing. Okay, the symbols. Yeah, yeah. Okay,
Yes,
thank you.
sir. Okay.
Yeah, fine. These two, I thought T1, T2 here. Okay, they should be T3. Yeah? Symbol it is. T3 should be. Okay, T2 cost, it should be T3. Yeah? Then check one symbols. Or if you want to write T naught, it's left to you. Anything. So T3 equal to M2G. So further substituting M1G by 2. Cost it will get eliminated. Negative sign. Oh, mg. So T3 is m2g plus kx equal to 0. Now what is the question being asked? Find the mass of the unknown load. That m2g is unknown, no? So what shall I do now? How to get m2g? Uh, from this equation, kx is what? Equal to in terms of eta x naught will come. And I'll bring that kx naught value, I'll substitute here, we'll get m2. I think problem is no need of equation 3. Substitute x in terms of x naught, then you'll get kx naught, kx in terms of m1g, substitute, you'll get the m2 in terms of m1. Answer will be 2 kg. Spring force can also set up. Tomorrow we'll take few more numericals where the spring force will come here. I think today almost you have come across torque due to tension, normal contact, torque due to friction, torque due to weight, torque due to spring force. Different types of forces. How do they set up torque? Till now what happened? We took about the forces concept. Tomorrow what happened? If a force which will vary with in space along x-axis, the magnitude increases along y-axis. So we'll take the force where all these are point forces. Am I right, all of you? What is m1g? It's a point force. It will act at one specific point. Now tomorrow we'll take a problems where the force will be acting throughout the length of the rod. Then how the torques will come? Because these things will help you next when you go for the electricity magnetism chapter. There the forces of that nature will come. Or when you go for fluid mechanics. So we'll explore such other types of forces. All these are like the force will act at one point. M1G will act at one particular point. Okay, try to work out numericals of different kind. Okay, don't get deviated here and there, because I feel this is the best topic to learn rotation, to enter into rotation mechanics. Once you are familiar with all the forces, everything torque, no, you can see the coming weeks, the rotation mechanics, you'll feel comfortable. And I suggest you have a physical ideas, the practical world, rectangular plate, square plate, hemisphere, sphere, cone, quadrilateral. If they are having different orientation, suspended, how do they appear? Until unless you don't know this, not possible. No? Rest all everything, torque we know very simple how to calculate, and we know mathematics also. Lack of that physical information, what when you are struggling it. The rigid body mechanics requires you must have the physical world. You should know you should open eyes and you should see the world outside. Objects around you, how they are. See, I'm telling this one, you might be surprised. Sometimes you lean books like this, no? There's nothing but the problem. You can